Hi friends, we'll wait for 2 minutes for the rest of us to join and then we are going to give it a start. Meanwhile, I'll just share my screen.
Hello.
Hi Rohit, I hope you can hear me clearly. I hope you can see my screen also. So assuming that, let's give it a start. So yesterday we were talking about doing a prediction of income on this set. So let's continue from there. So I'm just going to quickly import all my libraries. I'm already done with pandas. Let's go ahead with numpy. Then I'm going to import matplotlib, pyplot as plt, import cborn as sns, and import warnings. And what I'm going to do with this is warnings dot filter warnings, and I'm going to say ignore. Okay. So using this, I think I have all the required level of libraries in place. I'm not sure whether we will really be using NumPy or not, but let's see what we could do. Now what we are going to do, let's import the data. So I'm going to say, let's say df. Okay, I'm just going to say data frame. So pd dot read csv, and my data is no, yeah, this one, right? So df dot head, sorry, if I do a df dot head, I get the sample data. Now I could clearly see upfront there are a few problems. Not everywhere do we have work class, not everywhere do we have occupation. So these are things we have to take care of, right? And then we have a good, let's say combination of numerical variables, combination of the categorical variables. Obviously, our target variable is also a categorical variable. We have to do these kind of, let's say, the scaling things, and most probably we may not need scaling. We might need scaling with this FNL WGT column. Just have to see. I don't think we will need scaling, but we'll see what happens with capital loss and with capital gain and with hours per week and so on and so forth. Rest can be treated first of all for the presence of missing data, how to handle them most probably. And then what we can do, we can take care of the categorical variables using um, the encoding techniques, right? So let's do a describe. If I do a describe, I'll get a lot of information. Let's try to see what is happening over here. So first of all, I don't see even a single numerical variable which has any difference in the number of rows. So why don't I do one thing? Why don't I do one thing? I go to the previous cell and do a df info. Let's check the information first. Yes, I think I assumed this. My assumption was right. I have 32561 rows and I have total 15 columns. So 14 features, one target. And there are no null values because if you look at the describe output 32561 and 32561, that number is matching. There are no non-null values. So this looks like a testing data. It's not really an accurate one, but that's fine. So ignoring this, what can we find? Age, on an average age is 38. Okay, 38 and a half. Standard deviation, we can't say much about this right now, but we can only say what mean plus minus one standard deviation is where 65% of my data stays, or mean plus minus two standard deviations is where 95% of my data stays, right? So 38.5 plus two standard deviations means, let's say, 36. So 38 plus 36, 38 minus 36. So this is the range in which my 95% of my people fall when it comes to age. The minimum age is 17. 50% is the median. Median is quite close to mean, right? You see, mean is 38, median is 37. So it's good data. I mean, if we try to visualize this, that might help. So let's do a quick df age. If I do a disk plot, yeah, it's closer to a normal thing, right? It's not exactly normal, but it is close to normal. So the distribution of our no, the people who participated in this survey is overall good. It's not bad. The same applies to this one also, I believe. FNL WGT. Let's try and see. Okay, SNS dot diskplot df FNL WGT. I'll just press a tab and try to complete this. No, I was wrong. Things are more on the. So this is kind of right skewed. Okay, this is kind of right skewed. Then I have education num. Education num seems to be very, very well done. Education.num, because this I believe is a dummy encoded variable which is given inside the data. We may have to check the data definition once, but I'm quite sure this is uh, a dummy kind of a variable which is given as a rating, a ranking for what or how much people are educated, right? There is one error which we have got here. I'm not going to get rid of this right now. I would like to show you why this error occurred. This error occurred because I was doing something wrong. This way of doing a dot and calling the column name. So a data frame dot the column name, data frame dot the column name. That's intuitive for a programmer to do, because that is usually how we create objects also, right? So we create an object and we call the class, then we call the constructor, right? So that's one way in which what we do, we create the objects. That's one way what a programmer will think like. That's a bad way of doing. Okay, that's a bad way of doing, because depending on the name of the column, because here in the name of the column itself there is a dot. So that's why I should idle condition, right? I should idle condition use this combination. I should use a single quote and then a bracket like this. So this is a better way of doing it. Now, obviously, as you can see over here, it's a very controlled kind of a data, and it's not exactly normal, but it's really controlled, right? So this is a better way. This is actually what I wanted to say over here, is this is a better way of doing things. Then we have capital gain and capital loss. Okay, let's look at them also, right? SNS dot displot df capital. I just press tab, but seems my laptop is slow. So let me just. Oh, okay. Here is the problem. Fine. Oh, capital gain is concentrated mostly on zeros only. Why is it concentrated mostly on zero? DF capital gain. Let's do a dot value counts, and we will get this. You see, the what is happening over here is, if I do a head, top 5 values or top 5 occurring values, zero occurs for 29,000 times. Okay, zero occurs for 29,000 times. So this is one thing I wanted to mention. If there is an issue of bias, or having or not having proper distribution of outcome variable in the target. So we have already seen what is the problem with the target. Let's quickly look at the target. But I hope you remember what we saw in the last class. What that PDF file of yours was actually signifying, right? But let's have a quick look. So the column name is income. Okay, so the column name is income, and I'm going to do the same thing as I did over here. So I'll take the value counts. I don't need the head here, by the way, because there is only two values. There are two values. So you can clearly see in the target variable, I have a issue with the distribution of the data, because one class is like 24,000 times, another class is merely 7,800 times, which really signifies there is one class of sample, or the sample has a bias, a tendency to being attracted towards one type of people or one kind of response, as opposed to the other kind of response. Now, this is a problem. This is clearly a problem. We will not solve it right now. Later on we will find out ways to solve it. As I told you in the last session also, we will use things like SMOTE, right? SMOT. These are techniques that we can use to get rid of these kind of, or to handle this kind of problems. SMOTE is not a way to get rid of that. We cannot get rid of that, but we can handle it. But as of now, let's keep this question to our notebooks. Let's not take it into the practical aspects. But when it comes to features, if you have features where you have a lot of concentration on one value as opposed to other value, that's really going to be a problem. Okay, that is really going to be a problem. Even if you do a scaling, that might well be a problem. So we will see how we can take care of that. We will see at a later stage. We will see. Maybe we will drop the variable. Maybe we will do things like VIF and RFE to find out what is really, if at all capital gain is really going to have an impact on the explained variation of my model, right? If I am able to find that, then I can answer the question whether I really need capital gain or I can drop it. But let's go ahead with the rest. So I have capital loss hours per week. Okay, so let's see. The same issue here also. If I take this value counts sum, no, sorry, not sum, head. You see, 31,000, they fall into zero. There is some issue with these two fields. I would like to know what those fields mean. Control O, and I will go to downloads and I will open that file which you had shared me yesterday. Where is that file? 48, right? This was that file. Let me open this file. This is the one which you shared also yesterday. If you remember, let me see what is the actual meaning there. Capital gains of an individual, integer greater than or equal to zero. Capital loss of an individual, integer greater than or equal to zero. Exactly as I thought. Exactly as the name says, there is nothing right or wrong over here, right? But there is some issue. I mean, there are a lot of people with capital gain and capital loss being equal to zero is a concern. Either they are not investing at all, or they don't, or the person who collected this data, the way it was collected, maybe I'm just thinking out loud, maybe the way it was collected is where they didn't get good reliable sources to get the data. Most probably they converted it into zero. That can also happen. We don't know, right, how this data is really collected, so we can't really comment. But let's look at hours per week. Hours per week looks quite good, because if you see, mean is 40, but median is what? Median is also 40. It's almost same. Okay, mean value is 1, max value is 99. So the range is quite high, although standard deviation is not bad. But we can't say anything about standard deviation only at looking at the number. So let's hours per week. So what I'm going to do, sns dot dist plot, and oh sorry, sns dot, yeah, it's almost a normal thing. Not really normal, very skimmed at the middle part, but it is near to normal, right? It is near to normal. This is good. It's not bad. So overall, our variables, which are numeric variables, they look good to me. Other than these two, I have serious doubts. I have really serious doubts on this. So look at the max value. This is really a problematic value. I will tell you what is happening over here. This I know. I have seen in other use cases. This is where people don't know the value. They simply write it as 99999 or something like this. That can happen. Okay, that may well be the case. This looks realistic, right? But I have seen people entering values like these, or 1 2 3 4 5 6 like this, and so on. Maybe that's also the case with the value 0, because 75% of the values fall below 0, and all of a sudden the maximum value is this. That is a serious issue. I have similar doubts on this column also, but let's not jump into a conclusion right now. We'll do some more activities. For example, what we are going to do, this may not really work, but why not try this? Because yes, obviously, sense dot heat map df core comma annotate true. And if I do this, it's taking some time. Okay, let's wait. In the meanwhile, Rohi, if you have any questions.
No questions as of now.
This is very strange data. You see, there is not even a single variable which has good positive relationship other than one. I can see only one variable, only one, which is this. You see, education num and hours per week, they are somewhat positively correlated. So that's a good news, by the way. This is not a bad news. Education num and capital gain. Okay, capital gain is a very weird column, but they are also somewhat positively, somewhat, not really entirely. somewhat positively correlated, 0.12. Everything else is very, very small. You see 0.0 and something. So only these two fields, this one and this one, in case of the numeric fields, are actually making some intercorrelations, but they are not high. Now, because we did a df.core and our target variable is a categorical field, so what has happened is, in this case, none of my categorical fields are actually here, right? None of my categorical fields are actually here. So that's the reason why we are not able to understand what is the impact or the correlation between the features and the target, which we have to do. But for that, we have to do a lot of other things because we have to prepare the data. So let's try to do something. What we are going to do is that let's try to look for, let's say, missing values. Okay, let's try to look for the missing values. Okay, let's try to look for df head. I do remember that there was something with yes, work class and occupation. So df work class value counts head. Oh, sorry. Yes, of course. This is a function. So what we are doing, I don't need head here because this is a categorical column. So I can get rid of that. Now there are these many fields which are having a question mark. Question mark means that's not, uh, people are not aware, right? So df work class is na sum is na. There is no such count there. So okay, I can do a manual calculation also. That is not an issue. Df dot shape is what? 32561. Now the question here is 1836 divided by 32561. This is the percentage of null values. So what I'm going to do, I'm going to, okay, so I'm going to put a bracket over here. 5.64. 5% values are not available. We can drop them. We can actually drop them. So how can we drop them is the question. So we have to select those fields, right? Uh, or we can try to do this. Yeah, so work class has this, and what was the other field that has this? This is there in occupation. Occupation also has this. Okay, let's look at each and every categorical variable. Why not to? Why to take a risk, right? Why to take a risk? So what we can say is that, let's say df, okay, df underscore categorical, I'll say. Okay, df underscore categorical is where df select d types. This is a very, very cool function which we have. Here what we do, I say include. Okay, include only those fields which are objects. So I now have a categorical uh, df. Okay, I have a data frame which contains only my categorical fields. Now what I can do, I can try to apply some lambda function. So that's exactly what I'm going to do. Df categorical dot apply, right? I can do an apply, and here I can say lambda. Lambda for each and every x. Okay, for each and every x, find out x being equal to, or the value of x being equal to question mark, right? Let's try. Let's see if this works. I'll put this into double quotes. Okay, I'll put this into double quotes, and I want this on the column axis, and then I want a sum. Okay, so what I am saying, have I said it rightly? Let me cross check as it is executing. Give me all the columns, or all the values where I have question marks. So yes, of what I have work class, I have occupation, I have a native country. So these are those columns where I have that question mark value. I hope you got the calculation, right? So I'm doing a lambda calculation to find out the values x. find any x where the value of x is equal to question mark for everyone who is there in the axis 1. So it will loop through each and every column, go inside this data frame, and apply this lambda, which is simply finding out the rows or the entries which has the question mark on. Now I'm doing a dot sum, so that's going to give me the count, right? Now what I can do, I see this percentage is really very small, so my suggestion will be to drop them. Okay, my suggestion will really be to drop them because I don't think they are really going to add any value. So what I can do is that df where work class, okay, is not equal to question mark. So I get a true false kind of thing. If I select only that much part, I have gotten rid of any. So I can also cross check that. I can do a work class value counts and do this. Now the question mark is gone. You see what I'm doing here is this condition is actually filtering anything which has a question mark. I'm putting it inside the data frame df. So now this data frame over here until this point. Okay, forget this line. I'll just take a cut. So until this point in time, I have a data frame which has no question mark in my work class value. And now I have also proved it using this. So what I'm going to do, I'm going to replace my data frame df with this. And I'm going to do similar thing for, because this works, I'm just going to do a copy paste occupation. Okay, and I'm also going to do this using native country. Okay, because it is too small for me to be spending any efforts. Uh, let me see what has happened. The number of rows has come down, obviously. Everything is still not null. I was able to get rid of the not available uh, values, right? So that is taken care of. Now let's do some pre-processing, right? So what we are going to do in pre-processing, we can do, let's try to do a label encoding and then we'll see. So to do label encoding, what we have to do from sklearn dot pre-processing import label encoder. Right now, I have already told you why we do a label encoding and why we do uh, something else, right? So that I have already told you. So that is exactly what we are going to do over here. Go ahead, Rohit.
Yeah, so when we are using that info method, it is showing us not non-null things. But in reality, we had some entries by question mark.
Yes.
So is that any function, or can we modify it such that it also shows us like it has some dot or comma or question mark entries, or
No,
it
it can't write. Why? Because I'll tell you why. Okay. Let's create a string. A
okay.
string is there, a which is dot. A string is there, a which is, it's a question mark. Now, what is the type of a? A is actually a string. And what is the type of b? B is also a string, which means this is actually a value. So when you use this is in a function or info function, it's going to consider this as a value in that cell. So if I am having, let's say, missing value when I'm doing the data collection, somebody who has done the data collection did not find a value. Hence, that person, what it did, wherever there is a missing value, they put a question mark. Now the question mark has become a string.
Yeah, I got it. But I'm asking, is there any function, or can we modify this inbuilt function so that it excludes such entries, or it gives us that it includes some of these special characters which we might have uh, passed,
I'm not
like
really
like this
sure.
dot,
Let's
comma,
see.
string. It uh, it makes us aware
Null.
that your data includes such entries, although they are not non-null, but they include some of this special characters. Is there any function or parameter?
In case of info, no. That I'm aware of. That is not there. But if somebody has written some better library as of date, that I'll have to find out, because there are, I've heard of certain libraries which are there in pandas. I've never used them, which by means of one command only gives you the detailed descriptive statistics. But what you are saying is, if I have a list like this and I would not like to include 3 in any calculation, is there any function where I can specify, okay, you calculate the descriptive stats but don't consider 3?
Yeah, yeah, yeah. It can be also interpreted in this way. Yeah.
Right? Now, I am not aware of any such function other than what I did over here. So I identified and then I got rid of that.
Yeah, because it might also the with the our data might also include some dot or commentaries, and we might not be aware because there are 32,000 entries, and we can't just have a scroll down and we can have a look.
No, what
We're
that we
not
can do
sure.
from here. We can do that using the value counts thing, right? We can do that using the value count. So when I checked the value counts, I saw there is a question mark.
Oh, okay, okay.
Right? So that we can do from here. That we can identify. But then you are also right in saying that once we identify whether there was a dot or a question mark and so on, we have to get rid of that RSLs only. That is to the best what I know. Right? There is no function there which is going to do or to perform the all the calculations by ignoring a certain value. That I'm not aware. I don't think there is any.
Okay, okay.
Okay. Let's go ahead. We could have used one hot encoding also, but somehow I like label encoding because it tries to keep my data concise. So I'll start with a label encoding. Let's see how it goes, and then we are going to improvise from there. So LE is equal to label encoder. Now what I need, I have DF categorical, right? I have DF categorical, which is the data frame for the categorical variables. I'm simply going to do what DF categorical dot apply. Okay, I'm just going to do a DF categorical dot apply, and I'm going to say LE dot fit transform. Okay, I'm going to say LE dot fit transform. Now, if I look at DF categorical dot head, it has converted everything. Okay, it has converted everything into a number. Now, because I have done this using an inbuilt function, obviously we have seen this earlier also, because I've done this using an inbuilt function, there is no way I can control the classes. So whatever value it has given to these fields are entirely out of its own, right? So I don't know whether it has given 0 for male or female, right? Because I did not control it. I did not write a dictionary like I did earlier. In this case, I didn't do that, right? So let's see how it goes, and then we can see. Now what we can do is that how do I concatenate this? So I need to get these ones back, right? I have to get these ones back. So what I can do is that df categorical columns. These are the columns which I would like to replace. So from df categorical, I would like to take these values, put it into df. So what I can do is that df dot drop, okay, df dot drop, I can say df categorical dot columns, okay, axis equal to 1, okay, and I can say in place is equal to true. So I have dropped all the categorical columns from my original data frame, right? I have dropped all the categorical columns from my original data frame. Now what I can do, df is equal to pd dot concat, okay, and I have df and I have df categorical, okay, and I can put this into list. I have to put this into list. Then I have to say axis is equal to 1. So if I do that, what happens? If I do that, what happens? I get some nan values now. Why? Why do I get nan values? Okay, maybe I have done something wrong. Let me do it in a different way. Okay, let me do it in a different way. So what I'm going to do, df is equal to this, and then df is equal to pd dot concat df comma df categorical access is equal to 1. And then df head. So what I'm going to do, I'll put my cursor over here, go to cell, run all above. Okay, it will start from the beginning. Let it start from the beginning and come down over here. Let me see if this solves the problem. Because then why do I have not applicable entries? It shouldn't be there because I'm matching index by index. So it should match index by index. Okay, okay, okay. Of course, of course, of course. Just a moment, just a moment. Uh, this is no, 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 and not applicable. Why is this coming as not applicable? Let's see. If dot info 38.162 not null. But any n is considered over here. I'm not able to understand why this guy gives that categorical. Hmm. Why is there not applicable? Have I done anything wrong? Let me see. I don't see. Let me think about these three lines. Have I done this correctly or no? Have I really done this correctly or no? So what I am doing over here is in the filter condition, I have work class value not equal to question mark. Okay. I have work class value not equal to question mark. Okay. Not equal to question mark. So that's one thing. Just a moment. Just a moment, Rohit. Yeah, just a moment. Uh, yeah. Okay. But is there anything wrong that I have done over here? Occupation, native country. Is this really going to make any difference? I don't know. But it's good to try. Let me just change one setting in my keyboard because or otherwise it will be very difficult for me to. No, I did the wrong change. I should have not done that. So now what I'm going to do, I'm going to delete this. Okay, now I will come over here and say cell run all above. Okay, not sure until what point. No, it is running until the right thing. So let it run, and I would like to see what it is doing. Okay, this line will take some time because these kind of string operations usually takes time, or otherwise my laptop is too slow today. Not sure. So what I'm going to do, I'm going to yeah df dot head. Okay, now I have df dot head. Then I have df dot info 30162. Nothing has changed. Yeah, absolutely nothing has changed. From sklearn pre-processing, import. Okay. Mm, oh, yeah. Hmm. I understood what mistake I have done. It's the same thing. It's not going to matter, right? Whether I put access equal to 0 or access equal to 1, how does it matter? is really not going to matter because hmm, okay, then let me do here, come over here and do this, and I'm again going to run this value over here. See, that is where the problem is. It is not dropping the fields. It is not dropping the field. Then why is it not dropping the field? df not equal to question mark, right? So work class, okay, work class not equal to question mark. So this gives me the right thing. If I'm doing this, then why is it not dropping? Because if I have done this, then this value should change, right? No, this value will not change because I am making the changes in a different place. So I'm doing a calculation wrong over here. I should do this. Right now I have no such columns where I have this kind of values. This should work. I have head and then I have label encoder. Okay, so I'm doing label encoding and pre-processing dot label encoding. Okay, very good. Now what I am doing, label encoder categorical dot apply le fit transform, and then I'm looking at the head. So I have to re-execute them. Sorry, right? So now, hmm, hmm, no. I have not dropped them from there. So that is the reason why they are still there. I have not dropped them from there. I have to drop from that place also. I have to drop the question mark things from that place also. That is why it is not working. So what I will do, I will do this thing over here, and I'm going to say df categorical is equal to this. Okay, this I can do. Native country, then it should be occupation and it should be work class. So I'll take occupation, put it over here, and I'll take work class and I will put it over here. Right now, let's run this and see if this works now, because I think this was the error. Let's do a run all. Okay, let's see. Today my laptop is really very slow, man. Yeah, it worked. It worked. See, I had to drop from there. That is the exact mistake which I did. I'm joining two data sets. I'm doing a concatenation. One of the data sets I have removed some values. From the other, I have not. So that is why it was actually giving me n values. Right? When it is concatenating, it is not finding the a common value. It is like doing an outer join in SQL. Now I have the proper data. Good. I thought I did something wrong. That is where, okay. Now what we have to do, my income is still in 32. So what is my income? Let's look at income. df income dot value counts. And if I take this value counts, d type is integer. I have to convert this into category. So how you do that is you take this income field and you say df income is equal to df income dot as type. I think that was the function. Not sure why it is. No, oh, see, my laptop is quite slow. Category. So this should now work. So if I take the value counts thing from over here and put it over here, then it is still in 64, but its type is now a category. So if I do a df info, then I'll say that it is actually a category. And the reason why I did that actually, Rohit, is because this helps the classification algorithms to converge faster. Now, you might be wondering why I did not do this earlier, is because there are specific algorithms which will lead this kind of treatment. Example given, the decision tree. So if I want to make the decision tree, or for that matter, any tree based models, understand that these are the categories in my data, then I need to convert them into a category data type rather than a numeric data type. So they will be represented. I mean, the values will obviously be either a string or a number. Now it is a number because I have already done the label encoding. That is the reason why it is containing the numbers, right? But the way they will be represented will not be as a number or like a continuous variable like age. It will be represented as a category: yes, no, true, false, will we play or will we not play, and so on, right? So that's a good way of doing things. I hope until this point in time we are clear. If you have any doubts, please go ahead, else we can start with at least the initial version of the model. Let's see how it goes.
Yeah, no doubts.
Okay, okay, then what I'll do, from sklearn dot, what was the library, uh model selection, import train test split. No, uh, I did a typo. Train test split. Now what I'm going to do, X and Y I have to create. Okay, X and Y I have to create. So one way of doing this is I do a df dot drop. Okay, I do a df dot drop on income and I say x is equal to 1, but I don't say in place is equal to true. Okay, so this makes me X, or this gives me X, which does not have income because I have dropped it. Right, I have dropped it. Give me 1 minute. Uh, okay, okay. So yeah. So what we are going to do is that X dot head. Okay, fine. Now Y is very simple. Y is this. Y dot head is this. Okay. Now what I'm going to do, X train. X train. Yeah. X train. X test. Y train. Y test is equal to train test split X comma Y. Let's say test size I can also specify as a 30%, and the random state is equal to 101. Okay, now I have got X train and X test. Let me just see how they look like. So X train dot shape is this. Oh, sorry, shape is not a function, right? So X train dot shape is this. X test dot shape is this. Okay, X Y train dot shape looks like this. Y test dot shape looks like this. I hope. Oh, again I made that mistake. Sorry. Uh, this is not a function. Now I will assume that you got to the point why this is comma 14 and there is nothing called comma 1 and so on, because that this y is actually a series in which it is read. Right? It is actually a series. So it's actually a series. So that's the reason why it is kind of a 1D array. It's similar to a 1D array which we saw in NumPy. Right? That is the reason why this is how it is. So now that we have got this, let's start with the very simple decision tree classifier. Okay, now please pay attention here, because we are going to do some things which are right, which we are going to do some things which are wrong, because we have to do something wrong. We have to simulate that we are doing something wrong so that we can correct it. So decision tree classifier, this is the library which we have. Let me just run this. Let's see. I hope. Oh no. See, my laptop is really slow today, man. Okay, now I have to create an object. I mean, fitting the model is really very easy, right? We know this dt dot default let's say, is my model. So this is my default model, and I'm going to say a decision tree classifier. And now what I'm going to do, I'm going to pass a parameter over here. I know the parameter, that's the reason why I'm going to pass it, but you don't know that. So what you do, you take this, you come over here, you get the documentation of 0.23.2. Let me see which version I'm using. Pip show or pip show or pip status it was. So let's see if it is pip show. I think it is pip show only. So pip, no, it is not show, it is status. Ah, yes, show. Okay. So pip show scikit-learn, it says I'm on version 0.23.1. The documentation here is 0.23.2, which is fine, which is absolutely fine. Now in the decision tree classifier, we have a parameter which I would like to play with. Okay, this is one of my favorite, let's say, parameters. We are not going to call these variables or parameters anymore, because when we define function, if you remember, when we define function, or if you have yourself studies object oriented programming in Python, because we have not. Okay, we skipped that part because OOPS is not really day to day used in the data science life. It is used in the product development side of things, not in terms of, let's say, model building. But if you are already aware of the concepts, or if you are clear about the concepts of functions, when we create an instance of a class or an object, we create it using the constructor methods by passing some initial values. So when I create this object over here, right? When I create this object over here, if I just place run, it creates an object. Okay. What all are the options which I have? Okay. What all are the options which I have inside that object can be given using a Python command called dir. So if I do a dir, I could see these are all the most probable functionalities or variables which are available. Okay. Now, how did it get this? Is because this is the only place we will need object oriented programming in the entire life, in my, at least in my recent career while doing these kind of predictive modeling. I have myself not used any kind of oops things. Now what we are essentially doing over here is we are creating an object called dt default of the class decision tree classifier. This class was available in sklearn package. Okay, sklearn is a package inside which it was available, and tree is a module. Okay, sklearn.tree is the module. Inside this there is a definition of a class. So in simple words, sklearn package contains a tree.py Python file. As simple as this. That tree.py Python file is somewhere there in my laptop. Inside the tree.py file, I have a class which is called a decision tree classifier. Right? I have a class which says decision tree classifier. We can find out the Git repo also. Okay, for this, and we can find out that tree.py. Now I've created an object of that class, which is an instantiation of that class. So class is basically the blueprint. Object is just the representation, right? Now, when I'm doing this, I'm not passing any values over here, but if I want to, I can. And these are the values. We will go through any of them in detail. May not be in this current session because we are out of time. We have to close it now. But the one that the one that I like using is this one, max depth. Now, in programming world, if I pass any variable over there, I'll call it a variable, right? I'll call it an instance variable. In the machine learning world, we call this a hyperparameter. Okay. The reason why it is called a hyperparameter is because later on I'm going to tune these. I'm going to change the values. I'm going to find the optimal values of these inputs or these values, and that set of optimal values is going to lead me to getting a model which is stable. Now we already know that a model, also referred to as a stable model, is not the one where we have the highest accuracy. It's a model where I have a good stability, right? We have already seen that in the last logistic regression model which we created. Finally, we came down to a place, although our test score was really not good. We came down to a place where we had a model where we had good precision, good recall, and good accuracy, right? So these three things were actually at a mark, at a stage. We did not create a model where the accuracy was 93%, while the precision and recall was too high and too low and too scattered and so on. So that kind of a situation now, because we are going to look at advanced kind of, it's a modelings. So that kind of a situation can be arrived only, okay, not out of the box. We have to do something to the model. And by doing something, I mean we have to tune the model. And to tune the model, we need to tune the hyperparameters. And these all are the hyperparameters. This is named as the parameter, but they are in the machine learning world, in the mathematics world, they are known as the hyperparameter. The criterion is a hyperparameter. We will go through them. Okay, don't worry right now. What is a criterion, or what is a splitter? What is max depth? But max depth is my favorite of the hyperparameters because it says that's the maximum depth of the tree. So if I'm going to draw a tree out of this, so what is the maximum depth to which I would like to go? So I would like to start from somewhere. Let's say I would like to say max depth should be equal to 5, right? I'll start from some place and then we'll see how it goes. Okay. So I'll just shorten this output. And then what we are going to do, let's fit the tree. Before we close for today, let's fit the tree and see how it is going. So when we fit the tree, what we do is dt dot default, okay, dot fit x train y train. Okay. Now, oh, rather than creating as dt, I created it as df. So that's why it did not work. Now, because of the current version in which I am, it is not printing everything over here. It is simply printing the parameter I have passed. Ideal condition, it will also print, or in other versions of Anaconda, it will also print the default values, okay, the default values of the other classes. But if it does not print, we know where to look for it. This is the documentation. We know that hyperparameter criterion is already set to Guinea. We don't know what is this criterion, okay, but let's assume there is a parameter called this, which has a value this as of now. The only thing that we have overridden is max depth. By default, it is none. Okay, the nodes are expanded until all leaves are pure, or until all leaves contain less than mean sample split samples. So we will look into this variable also, but overall, what this max depth being none as a default value does it, the tree is going to expand as long as we don't get the pure tree, right? We've already seen that with our play and no play example, right? That's exactly what sklearn will try to do. Now that has a disadvantage. Basis my data or the size of the data, it might take a lot of time. And maybe if I have a lot of depth in my tree, which we will see tomorrow when we try to draw the tree, we will come to know that it is actually a problem because the more is the depth of the tree, the more efforts we need to explain the tree to somebody, right? The more is the effort we need to explain the tree to somebody, right? So we will look into that, but as of now, let's do one thing. Let's try to from sklearn.metrics, okay, okay, import class confusion matrix and accuracy, right? These two we need. Now we need y pred default, which is equal to decision tree default, and I will have to use predict and pass x test. And then here I would like to see what is the accuracy score, comparison of y test and y pred default. Okay, I see that the accuracy is 84%. Let's not get excited right now. 84% is good, but we don't know whether that's a stable thing or not. Now, what about the confusion matrix? Y test and y pred default. Okay, if I do this, I could see there is some problem. There is not a big problem, but there is some problem. At least I have, let's say, majority of my data around 7,500 rows. Okay, 7,500 rows out of my test set. Okay, in my test set, I have lesser data, right? I don't have 32,000. In my test set, I have only 30%, right? So approximately I'll have what? Approximately 9,000 rows are there, out of which 7,000 or 7,500 are the correctly classified ones. Okay, if I have 30% of 30,000, 30,000 being my total number of rows, my test size when I did a test trend split was equal to 0.3. So 30% of data is my test data, right? Which means I have now 1,000 rows, like 9,000 approximately. I have 9,000 rows, which is there in my test data, which means this much is like 7,500 out of 9,000. Not a bad job at all. 7,500 out of 9,000 are correctly classified, but 1,400 approximately are incorrectly classified. So these are the incorrect ones. Okay, and these are the ones on this diagonal are the correct ones. Okay, we will later on try to see if I can improve this, if I can use any different kind of, let's say, tree modeling to do this and so on. But the first thing we need to do, we have to understand what we did with this max depth. Okay, what is the actual meaning of these all the parameters which you have, the some things which you can see over here, mean, sample, split, and so on and so forth. Is there any other thing which we can use, mean, weight, fraction, leaf, and so on? Right, we can also go to the documentation here, and we can try to find out what all other things we have. What is, let's say, criterion, splitter, max depth, mean sample split, mean sample leaf, and so on. So we'll go through each and every one of them, and then we will try to employ some kind of a methodology by means of which we select the correct combination. Okay, the correct combination. Maybe the default ones were the correct, we don't know. We will find out first task. Okay, first task we will find the correct combination. But even doing this, even before doing this, what I would like to do, I've got the basic tree. The task number 0 I would like to do tomorrow. This will be really interesting. I'll use a library to actually draw the tree and see the outcome, because decision tree being such a direct and easy to interpret kind of a method can only be proven, that statement that I gave right now, that it is very easy to understand, it can only be proven if I draw the tree. So in case of a decision tree, I can actually draw the outcome, I can visualize it, and if I can really visualize it, I can explain it quite well. It is going to have some numbers, obviously, because this is a statistical model. It's going to have a few numbers, obviously. It's my job then to explain that to my peers who are not from the technical background, or who are looking for the outcome of the model. So we will look into how to draw, and then we will look into how to find the right combination of things. I think this is a logical stuff for today. Let's make it a close. If you have any questions, Rohit, you can always put it into the chat group. Is that fine?
Yeah, yeah. Okay, sure.
Okay. Okay, Rohit. Thank you.
Thanks. Good
Good
night.
night. Good night.